Hi, I welcome you to Remedial One YouTube channel. Today we are going to look at how we can able to evaluate the limit, which is for my elective mathematics student. It has come to my attention that most of you need a little help on that. So we are doing the video to cover the limit as it approaches infinity and the limit as it approaches a finite number, how different ways you can able to solve it in the WASSCE final exam. So that's what we're going to look at it in this video. Please go ahead, subscribe, share with your friends. So our first question, so we want to evaluate the limit as x approaches infinity for a 3x all on x plus 2. Anytime you want to consider the limit as approaches infinity, you have to look at what matters in that pieces. So here the numerator at the top here, we know that the whole of this, it matters because we have x over there and here we have x here. So these are the two that matters. Are the two, if we have a big number added to 2, the 2 will not prove any difference. So if that is the case, then you consider the limit as s approaches infinity 3x on x. But we have x here, we have x here, it turns into 1, so that goes away. So that gives us the limit as x approaches infinity of 3. And the limit as s approaches infinity of a constant is that constant. So, and if you can even also consider it a different way. So here we have the limit as x approaches infinity. So we got 3 big infinity over infinity plus 2. So as I said, you have big number and 2. The 2 doesn't matter. And here you got, it's multiplying to a big number, which is infinity. And now you have another number here. So that of them can go away. And this one already have been out. And it's 3. So that is how you can work this thing out. Now, when we have a limit as it approaches finite number, first of all, plug that into it. If you get a certain value, then that's good. If you get something that is undefined or 0, then you have to see if you can readjust it. So here, this is just a polynomial that doesn't have any fractional involved. So here, and it's a multiple choice. So here, all that you could do is that it's just -1. You plug it in there, -1 to the power 4 minus 3 -1. Wherever we see x, we replace it with -1 minus 7 times -1 plus 11. Okay, here is even number. Anytime you have a negative and it's even number, it's going to make it positive because negative times negative is positive. So here is going to be 1. Here, -3. There's even number here. So because of that, it's going to turn into positive. So 1. Negative times negative is positive. And then plus 11. So here, finally, as we are getting into our final raise, -3 times 1 is -3 plus 7 plus 11. You combine the positive numbers 1 plus 7 and plus 11, which is going to be 19. So here will give us 19 minus 3, and that will give us 16. So here the D is the correct option. So here we have a piecewise function, which is a function that consists of more than one piece, and now you have to able to know your domains. So here, numbers that are greater than what? 3. So it's 4, 5, and so on. Here, the numbers, you have to be greater or equals to -2 or less than that of that. So here, you can less that. I have to be -2, -1, 0, all the way to 3. That are the set of numbers that's supposed to be here. Here, the numbers that are less than -2, so -3, -4, -5, and so forth and so forth. So you have to be able to read the domain. That is what is going to matter. Okay, and now what they are saying that we want to find a limit as x approaches -4. So where does it fall? We see that it falls in here. The limit as x approaches negative 4, we are going to put it in 2x plus 3, and that becomes 2 negative 4 plus 3, and that gives us negative 8 plus 3, and finally we get negative 5. That's our evaluation answer. So the B is the correct option. Please go ahead and subscribe if you haven't done so. We want us to find a limit as h approaches 0. If you go ahead and put wherever we see h, we replace it with 0. And when we do that, here is h, so it's going to be 0, and then here over 0. Here, this one is undefined, or we say, yeah, it's undefined. Or when it happens like this, you can't select the answer to be 0. No, this is not. This is undefined, so you can't select 0. So you have to able to simplify a little bit. So here you see that h is everywhere. Limit as h approaches 0. We will take h out. We have 3 plus 2h. We have taken the one of the h out, and then the 4h squared, all divided by h. And h divided by h is 1, so it goes away. And at this time around, yes, we can plug it in. So when we plug it in, we got 3 plus 0 plus 0, and that is 3. So this become a good option. So anytime you plug the limit and you get, say, undefined or 0, then you have to simplify and then plug it in and get your answer. So you have to also know the difference of 2 square and all that. So here we want to evaluate. First of all, you plug in 2 in there. So when you plug in 2, you see that 2 to the power 4 minus 16 over 2 to the power 2 minus 4. See that we get 0 because 2 to that is going to be 0. Get 0 over 0, and this is undefined, so the A is not an option. Careful with that. So here we have to do a little simplification before we can do that. So the lim as x approaches 2, we are going to expand this one, x squared and squared. This is giving me a clue. Normally the denominator, we will try to see if we can get away with the denominator. And here 4 squared is the same as that. And then here we have this minus 4. Change dependent. So the limit as x approaches 2, here becomes difference of 2 squares. We got x squared minus 4 and x squared plus 4, all divided by s squared minus 4. Realize that we have the same, so they turn into 1, so they goes away. The limit as x approaches 2. Now we can plug it into here, which becomes of this one is just 2 squared plus 4, and that is 4 plus 4, and that's 8. So the 8, the D is the correct option here. And you have to be master of how you can able to factorize your quadratic. As a elective mathematics student, you need to know that. Or higher mathematics student, you need to know that, because most of the limit they will bring a lot of that. Okay. So here, when we plug in 1, we realize that here we are going to get 0, and then here we are going to get 0. So that will not work. So because always try to plug in first to see if you're going to get a good number. But when you do this and you got undefined, that's where you have to simplify. So we are going to simplify the limit as x approaches 1 of. So you're solving this quadratic. This is a constant. So first of all, you do this, and you take your constant, and you're looking for 2 numbers. You multiply, you get a constant, which is going to be 1 and 2. And when you add, you have to get -3. So when you add it, you gotta get -3. So what you could do, so that means -1, -2. Okay. So once you get that number, you bring it here, -1, -2. So you check, see that this and this are looking the same, but it kind of is a little bit flipped. So you have to do something about it. So what we could do, we can flip this one whereby we multiply both sides by negative. So when we multiply to the limb as x approaches 1, we multiply the numerator by -1, we can flip this one to be that. And then here x minus 1 to parenthesis x minus 2. If that is the case, this is like term over there, so they cancel out, they turn into 1. So now we got limb as x approaches 1 for -1 over x minus 2. And then we can plug it in wherever we see x, 1 minus 2, which is equals to -1 over -1. And that is 1. So here C is the good option. Okay, let's look at the last one here. Please go ahead and subscribe if you haven't done so. So here, as we plug in -3, so first of all we have to do that. So as we plug in -1, so let's see, as we plug in, I checked the bottom here and I realized I didn't get 0, so that tells me that I have to do it properly. That might be a straightforward substitution. So always do that. This. So here is going to be 2 and 3 squared plus -3 minus 21 all on -3 and -3 here. And that gives me, this here is going to be +9 and 18, and then -3 minus 21 all divided by -6. 18 minus negative, we put it together, so -24, then -6, give you -6 over -6, and that give you 1. So this is a good one. We plug it right away and we get our answer. Since we didn't get 0 divided by 0, which is undefined, here we are getting a finite solution. This is a good one. So the answer is, thank you very much for being with me all the way to the end. Please subscribe, like the video, and leave us a comment and share with your friends. Bye bye. Be blessed.